Hello viewers, welcome back to my channel Learn with Ravi. In today's session, we shall learn about the concept of clones. In the previous two models, we have seen how to find the mirror image and we have seen how to find the angle at a given time. And now, in model 3, let us learn how to find the time at a given angle. Between 3 and 4, if the angle between the minute's hand and the hour's hand is 60, then what is the time possible? So this concept is all about finding the time at a given angle between two hour spaces. So let's learn how to do these things in detail. So as I told you, we got approaches in plenty. I'll stick to two approaches. Approach 1 is using the formula and approach 2 is the concept. Let's get started with the formula part. So using formula, the same thing we have learned. What we have learned, that for a given angle theta, we have learned that theta is the modulo of 11 by 2 times mm minus 30 hh. Now we simply plug in the value of hh and mm and we got the angle there. And here you are given the angle and you are told to calculate mm for a given hour space. So we use the same formula to work with the concept. There are few things to be kept in mind. What are the few things? We have a word called as coincidence. When two hands coincide with one another, the angle theta is 0 degrees. So please keep that in mind. And similarly, you know that at right angles the angle is 90 degrees. And when somebody says the word opposite angles, it means that theta is at 180 degrees. Claim that. Now moving ahead. At what time between 4 and 5 will both the hands coincide? As he used the word coincide, the angle will be 0. So he said between 4 and between 5, he wants us to find the time where the angle is 0. Now we use the same formula, 11 upon 2 mm minus 30 hh is theta. So given theta is 0, right? And as we want to calculate between 4 and 5, we take the first hour space value, that is 4 o'clock, the minimum value. So we plug in the answer as the hh as 4 because common sense says definitely the time would be after 4 and before 5. So after 4 at some time the angle is 0. So we use the word hh as 04. Now plug in the values. 11 by 2 mm minus 30 into 4 is 0. So we get the value of mm as 21 and 9 by 11. The time would be at 4, 21, 9 and 9 upon 11. At that time the angle between the minute hand and the hour hand would be 0. Clear? Now in the next example, at what time between 4 and 5 will both the hands be opposite to each other? And when I use the word opposite to each other, the angle will be 180. So we have the same formula and given theta is 180 degrees and I told you that we take the hh as 04. Now plug in the value, 11 by 2 mm minus 30 into 4 is 180. Now working with the value, you get 11 by 2 mm is 300 and that is basic math. I need not explain how you get 300. So 180 plus 120 becomes 300, isn't it? Now calculate the value of mm, you get mm as 54 and 6 by 11. So the time is at 4:54 and 6 by 11. The angle between the minute space and the hour space, the minute hand and the hour hand will be 180 degrees. You can visualize that. Okay. Please do not assume any answers because in this kind of models you cannot assume the answers. Now the third example, at what time between 8 and 9 will both hands be opposite to each other? The same example, and I have taken this example because we have a small change here. What is that? So angle is 180, hh is 08. Now plug in the values. Now you got 11 upon 2 mm as 420. You cannot have 420 because the maximum angle in a clock is 360 degrees. So as the angle when you calculate is more than 360, subtract 360 from that obtained angle and that would be 60. So it is one full circle plus some extra angle, right? So it is 420 we got. So as 420 is more than 360, subtract 360 from 420, you get as 60. Now find the value of mm, and the value of mm is 10 and 10 by 11, right? So at 8, 10 and 10 by 11, the minute hand and the hour hand will be opposite to each other. In this example, the new thing what you have learned is, while calculating, if the angle you obtain is more than 360, please find the difference of the obtained angle from 360 and take that one as the proceeding thing. Clear? So that makes your solving part easier. Now going ahead. At what time between 7 and 8 will both hands be at right angles? Now right angle story, if you can visualize right angles, there are two possibilities, isn't it? So the formula is there and the right angle is given as 90, so and we take it as 0.8. Now we have two possibilities. Why we have two possibilities? Because common sense say the minute hand and the hour hand will be at 90 degrees in two cases, and as we have the modulo, we remove it, we get plus or minus 90. So case 1 is plus 90, case 2 is minus 90. Plug in the values, find mm value in case 1, and the answer is 754 and 6 by 11, and in case 2 mm is 21 and 9 by 11. That time is 721 and 9 by 11. So there are two times where the angle between the minute hand and the hour hand is at 90 degrees. I hope I am making sense. Clear? So this is how we calculate the time between two hour spaces for a given angle. Okay. Now plugging in the values, solving it is a little complex. Now we have a direct approach of solving them without using the formula. What is that story? Now the question is, at what time between 4 and 5 will both hands coincide? Now the minute hand coincide with the hour hand between 4 and 5, isn't it? So the diagram, please watch it. So you observe that the hour hand is between 4 and 5, followed by the minute hand, the blue color thing. Right, I made a difference, the shorter hand and the longer hand, and you observe that you have that happening between 4 and 5 only, isn't it? So we choose the minimum value HH as 04, and 04 indicates 20 minutes. Yes, so the answer is between 20 and 25, you will get the answer. I mean the mm value will be in between 20 and 25. So directly write the mm value as 20 and 20 by 11. The shortcut tip is, please write the value of mm as 20 and 20 by 11, and we can write 20 by 11 as 1 plus 9 by 11. So the time would be 4, 21 and 9 by 11. So you need to calculate after how many minute spaces you will get the possible answer. Once you get the minute space, that is minute space and minute space upon 11. So you found that the time will be after 20 minutes, between 20 and 25. So take the minimum value as 20. So answer is 20 by 11. That is as shown in the figure. Example 2. At what time between 4 and 5 will both hands be opposite to each other? Now please, you got to visualize things. That's it. Just visualize. No formula, no nonsense. So opposite indicates the hour hand will be in between 4 and 5. So the minute hand will be in between 10 and 11. See the diagram? The diagram explains, it is self-explanatory. And the hour hand is between 4 and 5. The minute hand should be in between 10 and 11. So 10 indicates 50 minutes. So the answer would be after 4:50. Isn't it? So the value of mm is found 50. The answer is 50 and 50 by 11. That's how you get the value of mm. Once you got the minute space after which the time is possible, 50 is 50, 50 and 11. So you get the answer as 50 upon 11 is 4 plus 6 upon 11. So the time would be 4:54 and 6 by 11. So that is how you calculate the time at a given angle. So what are we doing? We are trying to find after how many minute spaces is the answer possible. Once you get that minute space, it is minute space and minute space by 11. You got in the previous 20 and 20 by 11. In this example, you got the minute space as 50, that is 50 and 50 by 11. Now going ahead, let us take one more example. Now the case of right angles. We have done the same three models, same three examples using the formulae. Now I am trying to tell you the same three examples using the concept directly. Right? So the minute hand will be in right angles to hours between two slots. Now what are those two slots? See on the screen, the image is clear to you. So the hour hand is in between 4 and 5. And the minute hand is in between 1 and 2 is case 1, 7 and 18 is case 2. Yes or no? So, case 1 between 1 and 2, I take the minimum value 1 is 5 minutes. So, after 4, 5, we get the answer. The answer is 5 and 5 by 11. So, the time would be 4, 5 by 11. Now, what is case 2? Between 7 and 8. So, after 4:35, we have a possibility. So, the answer is the value of mm is 35 and 35 by 11. So 35 upon 11 is 3 plus 2 by 11. You get the answer as 438 and 2 by 11. So this is how we calculate the answers directly without using any formula. You need to assume the clock, the minute hand and hour hand position. Once you get the minute hand position, then we do it directly using the applied or the told concept. So at what time between 4 and 5 will both hands be 13 minutes apart? In this problem, he is specific asking us to find the time between 4 and 5 where the minute hand and the hour hand are 13 minutes apart. So to solve these kind of problems, we have an approach where we use the concept of clocks. In general, the minute hand gains 55 minutes over an hour hand in 60 minutes. What do you mean by that? By the time the minute hands makes one single rotation, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The hour hand will move for only 1 hour space. So minute hand moves 60 minute spaces, whereas hour hand moves only 5 minute spaces. So the time gap is 55 minute spaces. So we say that in general, the minute hand gains 55 minutes over an hour hand in 60 minutes, that is in 1 hour. So to solve this question, we have two possibilities. The first possibility is a case where the minute hand is 30 minutes before the hour hand, and case 2, we have a case where the minute hand is 30 minutes after the hour hand. So going to the story, so to be 13 minutes before the hour hand, the minute hand should move 20 minus 13, that is 7 minutes. Now have you got 20? 4 indicates 20 minutes, so 20 minus 13 is 7 minutes. So walking the story, the diagram is pretty clear. So you find that the minute hand is after 5. So to gain 55 minutes, we have 60 minutes. So to gain 7 minutes, what do we have? So we calculate it and we get as 7 by 11. So at a time called as 4, 7 and 7 by 11, the minute hand and the hour hand are 13 minutes apart. So going ahead, if you watch the case 2 where the minute hand is 13 minutes after the hour hand, so we take it as 20 plus 30, that is 33 minutes. So for 55 minutes, it is 60 minutes. For 55 minute gain, it is 60 minutes. For 33 minute gain, it would be how much? So calculating the value, the time would be 4:36. So at a time called as 4:36, the minute hand and the hour hand are differing by 13 minutes. So this is how we do it. The same problem can also be done by using a formula. So the formula is 12 upon x times 5x plus or minus t, where x is the first half space and t indicates the time minutes apart. So plug in the value. So one is 12 upon 11, 5x plus t, and other is 5x minus t. So just put in x as 4, t as 13. Case 1 is 4 hours, 7 and 7 by 11, and case 2 is 436, and that's how we solve the same problem where we have the minute hand and the hour hand by minutes apart. So this is one model of finding time at a given angle. Clear? Now going ahead, let us learn few facts about the clock. So the hands are in the same straight line when they overlap or when they are opposite to each other. So overlapping is called as coinciding. So when they are coincident or when they are opposite to each other. Now let us have some facts. So every hour both the hands coincide only once. So between 1 to 2, 2 to 3, 3 to 4, 4 to 5. So in every hour in the 12-hour space, the minute hand and hour hand will coincide only once. Now does it mean that in 12 hours we have 12 coincidences? No, we have only 11 coincidences. Why it is only 11 coincidences? We have a point. It is because in between 12 and 1, the minute hand and the hour hand coincides only once. So instead of 12 we have only 11 coincidences. So if it is 12 hours, 11 coincidence, 24 hours will be double, that is 22 times coincidence. Now going ahead, in 1 hour the minute hand and the hour hand will form two right angles. The minute hand and the hour hand will make right angles for only 22 times in 12 hours. So 44 times in 24 hours. Okay, the same thing happens with story of 180 degrees, straight angle. So in 12 hours it is 11 times. Why 11 times? Between 5 and 7 happens only once at 6 o'clock. And the same thing is found in 24 hours only 22 times. And here comes the most important point. What is the most important point? If both the hour hand and minute hand move at their normal speeds, very important word, at normal speeds, then both the hands will meet after 65 and 511. Now let me start with a small example. Assume that by time is 12 o'clock sharp. Yes, the minute hand will make one complete rotation. The minute hand will come to 12 again, and the hour hand will come towards 1. Yes or no? They don't again meet. Now this minute hand again, if it starts moving, the minute hand will coincide with the hour hand after 1. Right? So that time we have already learned the story, right? It is 5 and 511. So 60 plus 5 and 511 is 65, 5 and 511. So the minute hand and the hour hand will coincide after every 65 and 511 minutes. So please keep that point in mind. That is, the minute hand overtakes hour hand after every 65 and 5 by 11 minutes. Now we have some beautiful concepts of problems of clocks gaining or losing time. I'll start with the basic question and I'll give you some beautiful medium level questions also. First one is, a clock is running fast. What do you mean by running fast? It is called as gaining time. It means that when a normal clock covers 60 minutes, the faulty clock will cover more than 60 minutes. Or we have a concept called as clock is running slow. When the clock is running slow, it is referred as losing time. That is, if a regular clock makes 60 minutes, the faulty clock will make less than 60 minutes. That is called as running fast, running slow, or gaining time and losing time. So let me give you a small example of how it works. If the correct time is set to 5 o'clock, then I have a small table which tells you what actually happens. So if a clock gains 5 minutes for every 1 hour, clock 1, clock 2 loses 5 minutes every 1 hour. So the actual time will be at 6. Then a clock which gains 5 minutes will show 6:05, and the clock which loses 5 will display 5:55. The same thing after 2 hours, the actual time will be 7, whereas the clock which gains 5 minutes will show 7:10. Why got 7:10? 5 minutes in first hour, 5 minutes in second hour. So it is 7 plus 10, it is 7:10. Now coming to the faulty clock which loses 5 minutes every 1 hour. First hour 5, second hour 5. So 5 is 10. So it loses 10 minutes. So 7 minus 10 would be 650. The same thing after 3 hours, 4 hours, 5 hours. You find clocks gaining time. You have clocks losing time. That is the time they display. Is that clear to you all? It should be quite simple for you all. Now let us do some problems on this case. A clock is set to right time at 8 o'clock. So a clock is set to the right time at 8 a.m. and the clock gains 5 minutes for every 60 minutes. Then find the time displayed by the clock at 8 p.m. At 8 a.m. the clock is set to the right time and that clock gains 5 minutes for every 60 minutes. So at 8 p.m. what is the time displayed by the clock? So between 8 a.m. to 8 p.m. we have 12 hours. Don't ask me how, it is quite simple. Now it is given that for every 60 minutes, for every 1 hour, the clock gains 5 minutes. So 1 hour, if it gains 5 minutes, in 12 hours, it gains how much? It gains 60 minutes. So in 12 hours, that particular clock should gain how much? 60 minutes. So 1 hour extra. Now what is the time displayed? So the actual time should be 8 p.m. but it says 8 p.m. plus 1 hour, 60 minutes gain. So the clock displays 9 p.m. Simple. So 1 hour, 5 minutes gain. 12 hours, the gain is 12 into 5, 60 minutes. So at 8 p.m. the actual time is 8 p.m. So if it is the correct clock. So but as the clock is gaining time, it is 8 p.m. plus 60 minutes, that is 9 p.m. So that is how we solve the stories. Now going ahead. The same story, a clock is set to right time at 6 a.m. and the clock loses 2 minutes for every 30 minutes. Please keep in mind, the clock is losing time. In the previous story, the clock is gaining time, now it is losing time. Then find the time displayed by the clock at 10:30 a.m. the same day. So 6 a.m. to 10:30 a.m. it is 4 hours 30 minutes. So 4 hours is 8 half an hours and plus 1, so it is 9 half an hours. So that 4.5 hours is 9 half an hours. Why I am saying 9 half an hours? Because we have a time for every 30 minutes. For every half an hour, the clock loses 2 minutes. So it is given that for 1 half an hour, the clock loses 2 minutes. For 9 half an hours, how much? So for 9 half an hours, it loses 18 minutes. So at 10:30, the time displayed will be 10:30 minus 18 minutes, that is 10:12. So that's how we calculate the problems where the clock will gain time, where the clock will lose time. Clear? Now moving ahead with the next example. A clock is set to right time at 6:30 a.m. on a Wednesday. On a Wednesday, a clock shows 6:30 and the clock loses 5 seconds every 1 hour. Please keep it in mind. The clock loses 5 seconds every 1 hour. Then find the time displayed by the clock at 8:30 p.m. on the next Wednesday. On one Wednesday 6:30. Now he is asking us to find the time displayed by the clock at 8:30 p.m. on the next Wednesday. And he gave us that the clock loses 5 seconds every 1 hour. So Wednesday 6:30 a.m. to next Wednesday 8:30 p.m. the time is 7 days 14 hours. The clock loses 5 seconds for every 1 hour. So as the time duration is found in days, let us calculate the number of seconds lost for every 1 day. So it is given that in 1 hour we lose 5 seconds. We work with the clock. So for 24 hours, what is the time lost? When we calculate that, it is 120 seconds. So the clock loses 120 seconds by the end of 24 hours. That is 2 minutes. So if the clock loses 2 minutes in 1 day, in 7 days it loses how much? 7 times, so it is 14 minutes. So the clock loses 14 minutes in a week. But we have a time gap of 7 days and 14 hours, isn't it? So let us find the time lost in 14 hours. In 1 hour, it loses 5 seconds. In 14 hours, it loses how much? 14 into 5, that is 70 seconds. So 70 seconds is 1 minute 10 seconds. So on the whole, it loses 14 minutes in 7 days and 70 seconds in 14 hours. So the overall loss is 8:30 p.m. minus 14 minutes and 1 minute 10 seconds. So the time displayed on the clock would be 8 hours, 14 minutes, 50 seconds. Am I clear to you? It is 8 hours, 14 minutes, 50 seconds. The next example, two clocks are set correctly at 10 a.m. on particular Friday. The first clock gains 2 minutes per every hour and gains twice as much as the second. What time will the second clock register when the correct time is 2 p.m. on the following Monday? Now, 10 a.m. Friday, 2 p.m. the following Monday. The first step is, let us calculate the time gap between 10 a.m. Friday to 2 p.m. Monday. So using your basic math, it is found to be 76 hours. So 10 a.m. Friday to 10 a.m. Saturday is 24 hours. 10 a.m. Saturday, 10 a.m. Sunday is 24 hours. 10 a.m. Sunday to 10 a.m. Monday is 24 hours. So 24 is 72. 10 a.m. to 2 p.m. is 4 hours. 72 plus 4 is 76 hours. Simple. Now it is given that, see the line 2 carefully. The first clock gains 2 minutes per hour, and that gain is twice as much as the second. If the second gains x minutes, the first should gain 2x minutes. And he gave us that the second gains 2 minutes. So common sense says the second gains only 1 minute. Okay. Now for every hour it gains 2 minutes. In 76 hours, what is the total gain? It gains 154 minutes, which is 2 hours 32 minutes. Which is, now coming to case 2, second clock gains every 1 hour, it gains only 1 minute. Why you got 1 minute? Because the first clock gains twice as much as the second one. The second gains 1, the first gains 2. So finding it again, the second clock gains 76 into 1, 76 minutes, which is same as 1 hour 16 minutes. And add these things, you get display of clock 1 and you get display of clock 2, which is 4:32 p.m. and 3:16 p.m. So this is how we solve a model in clocks gaining and losing time. Next example, we have a story that says for every 1 hour a clock loses 5 minutes and another clock gains 5 minutes. We have two clocks, first one is losing 5, second one is gaining 5. Then they are set at 8 a.m. to the correct time on a Wednesday. Then the question is, when will they be 12 hours apart? 12 hours apart. So let us see the example. At 8 a.m. clock 1 is at 8, clock 2 is at 8, the time gap is 0. At 9 a.m. the actual clock shows 9, whereas the faulty clock which is losing 5 will show 8:55 and the clock which is gaining 5 will show 9:05. 8:55, 5 minutes, 9:5 is 5 minutes. So the time gap between these two clocks is 5 here and 5 here, which is 10. To make 8:55 as 9:5, 9 and 9:5. So it is 5 and 5 is 10. So we have 10 minutes time gap. After 1 hour, we have 10 minutes time gap. After 2 hours, what do you observe on the table? 9:50 here, 10 here. The time gap is 20 minutes. So for every 1 hour, we have a time gap of 10 minutes. So to find a time gap of 60 minutes, we need 6 hours. We observe that after 6 hours, clock 1 and clock 2 are apart by 1 hour in the table. Now the question is, after how many hours are they apart by 12 hours? So it's a simple basic math. So what do you get the answer? The answer is 12, that is 72 hours. Now add this 72 to the time given, you will get the answer. So 8 a.m. Wednesday plus 72 hours is 8 a.m. Saturday. So on 8 a.m. Saturday, the clock 1 and clock 2 will be apart by 12 hours. Before I teach you the next model, I want to give you a small concept using which a model can be solved easily. We have learned that the minute hand and the hour hand will coincide after every 65 and 511 minutes, isn't it, at normal speeds. But by chance, if the minute hand coincides hour hand at a faster pace or a lower pace, then how do you find the gain or the loss? We have a formula for that, that is 720 minus 11 minus mm times 60 times 24 by mm. We can solve this formula, not a big deal, but please remember this. Now based on this, let us do a small example. The example says the minute hand of the clock overtakes our hand at 65 minutes only. It should be 65 and 5:11, but he says that the minute hand is overtaking after every 65 minutes. So the clock is gaining time, right? Now the question is, find the clock gain or loss. So mm value is 65, plug in the value, you get the answer as 10 and 10 by 11. So as the result is positive, we say that the clock is gaining 10 and 10 by 143 on the particular day in the clock. So the clock gains 10 and 10 by 143 minutes. You can say that the clock gains or loses in the given number. Generally, the minute hand should cross our hand after every 65 and 5:11. If it is before that, it's a gain. If it is after that, it's losing time. Clear? Now, so please keep that formula in your mind. Going ahead, a clock is 5 minutes slow at 4:35 p.m. on Monday and 12 minutes fast at 5:45 a.m. the following Monday. On a particular Monday, the time shows 4:35 p.m. but the clock is slow by 5 minutes. On next Monday, the time showed is 5:45 but the time is 12 minutes fast. So to show 5:45, it should overcome this 5 minutes and it should gain the 12 minutes. He said the clock is gaining uniformly. So it should gain this 5 and this 12. So it means that the overall gain is how much? 17 minutes. Let us learn how it is done. So the time gap between Monday to Monday is how much? 4:35 p.m. to Monday 5:45 a.m. is 157 hours 10 minutes. Now if you convert that 10 minutes into hours, it is 157.167 hours. Now we observe that the clock is gaining 17 minutes. How you got 17? Initially the clock was slow by 5 and the clock gained 12. So it has gained this 5 and this 12. So 5 and 12 is 17. So in 157.167 hours, the clock gained how much? 17 minutes. So if 17 minutes gain requires 157.167 hours, to gain 1 minute, what the time required? So simple math, the time required to gain 1 minute is 9.25 hours, which is 9 hours 15 minutes. I converted 0.25 hour into minutes. I got 9 hours 15 minutes. Now the question is, if the clock gains uniformly, when did it show the correct time? Initially the clock is slow by how much? 5 minutes. If the 5 minutes are filled, if the clock gains 5 minutes, then it shows the actual time, isn't it? So to gain that 5 minutes, let us do the math. It gains 1 minute after every 9 hours 15 minutes. So to gain 5 minutes, it takes 5 into 9 hours 15 minutes is 46 hours 15 minutes. So after 46 hours 15 minutes, the clock shows the exact time that will be on 2:50 p.m. Wednesday. So this is how we calculate the problems of times which are slow, the clock which are slow, and then displaying the correct time. So I tried covering all the models of clocks with enough examples, and I want you all to spend some time, do some practice. If you get any doubts, please post in the comment section and I will be ready to help you. Don't forget to like and subscribe, and that's for now. Thank you all.